Welcome to science class, boys and girls. Today we're going to be talking about investigating groundwater. This is our lesson today. You should have printed out or picked up a copy of this 3-page handout for activity 61 called Investigating Groundwater. And I want to start out with a couple of kind of open-ended questions for you. So the first question here, if you can see it on my board, is, and I want you to write this down. There's a place on the handout for you to write it down. Where does water go when it falls to the earth? And I have my student out here in reality land, just off camera. Rachel, yes, can you answer this question for us?
When water falls to the earth, it falls into different rivers, other bodies of water. It may also just land on the ground in whichever watershed it happens to be in.
Okay, so rivers, ground,
other bodies of water,
other like oceans, okay. Lakes. All really good answers. Does it fall on you?
Yes.
Does it fall on your dog? Yes. Okay. And then the next question is, how does water disappear? It disappears sometimes, it seems like, into the solid ground. Where does it go? Can we get it back once it's disappeared? What do you think, Rachel?
Well, once it's disappeared, if it's a non-permeable layer, it's going to evaporate via the sun, the heat from the sun and whatnot.
Non-permeable, big word for a 6th grader.
If it's permeable, it's going to soak into the ground via the porous material that is the soil, and it'll undergo some leaching processes.
Ooh, leaching, not a big word.
It ends up in the groundwater in a big underground cave, essentially, full of fresh water. The rest of it is used to fertilize plants.
Excellent answer. Maybe you don't need this video today. So what we're going to start, hopefully you all got a similar answer to our A student here, Rachel. And now I'm going to read the introduction for you, which is the next thing on your handout. So let me share our screen. We have it opened, I thought, right here. Okay, so read along with me. Water can be found in many places, on the ground, in the air, and below the Earth's surface. Precipitation that falls on land may run off into lakes, rivers, and oceans. But some of this groundwater will go below the Earth's surface. This is where it's called groundwater. So that's our key vocabulary for today. Groundwater is what we're going to be talking about. About 50% of the water used in homes in the United States comes from water sources on the Earth's surface, such as lakes. 50% of the water in our homes is coming from lakes. The other 50% of the water comes from the groundwater, from this invisible sinking into the ground water. Some people have wells that connect directly to groundwater. I don't think we have a lot of wells around here in the city, but maybe some people in rural areas have wells. While others received water piped in from wells operated by local water districts. So that's what we have here. We have a local water district called AMP. Is it? No, East Bay Mud does our water. Because groundwater is so important to so many people, some hydrologists, a hydrologist is a scientist who studies water, specialize in the study of groundwater. Very important, critical role in our communities, in our infrastructure. In this activity, we'll investigate how water interacts with different materials in the ground. How our student earlier was telling us about porous versus non-porous. We're going to specifically be looking at those two things. So now I want you to write down the challenge or the purpose of today. How does water interact with earth materials? Where's my eraser? Where is my eraser? Did you take my eraser, honey? Did you take that napkin? Oh. Okay, oh, this works just as well. So the purpose, the learning outcome for today, we want to write down is How does water interact with earth materials? How does water interact with earth materials? That is the main focus for today's lesson. So here we have a picture of a hydrologist taking some samples from the groundwater. So he has a pump. This is a very long tube coming from a pump, and he's filtering it into this little bottle so he can take it back to the lab. Okay, so we don't all have the materials, you know, because we're at home. And so I have a video to show you of what we will be doing if we were still in class. So before we watch the video, you are going to need to take a look at this chart on page 2. So you would be drawing this in your notebook if we were at school, but we have one on our handout. And basically we're going to make 2 observations. We're going to make an observation of the sample without water, and then we're going to make an observation after we add the water. So you'll be watching the video. There's no talking on the video. It's just somebody pouring water into sand and then pouring water into gravel and then watching them for 5 minutes. We're going to fill that in and investigate how water travels, predict through which material it will travel more quickly, explain your reasoning. It's not very easy to see. And there's some a little bit more dusty colored water in this one. This was the sand one. No. Yes. So, and the amount of water. Did you notice the one on the left had a lot more water than the one on the right? Okay, so here we are at 11 minutes. Let's stop this. And let me give you guys a minute. You can fill in your data table, and then we will talk about the analysis question. So I'm going to pause it here. Pause the movie. Pause share. I don't want to do that. I want to pause the movie. Okay, so I hope we had time to finish recording your observations from the video that we just watched, and you could watch it again because you have access to the link. And we were supposed to predict before we poured it in which would be faster, the water traveling through the sand or traveling through the gravel. So I bet you we had a bunch of mixed results. Let me ask my handy dandy student right over here. Rachel, do you think it will travel faster through the sand or faster through the gravel, and why?
I thought it would travel faster through the sand because
You did.
Sand is on the beach and there's water.
Nice. And you can see it seeping in really fast, right? It's like,
right.
Very good. Okay. So now we're going to move right on to the analysis questions. So I'm going to share the screen with you, I think, and show you the questions. So there's 3 questions. Through which material did the water travel more quickly? How did this result compare to your initial reaction? So hopefully you saw that it went right through the gravel, like there's so much empty space, right? So this compared to some of your initial predictions correctly. Some of you maybe had, like our friend Rachel over here, she had to reassess for her answer. And in fact, once she watched the video, she saw that it went quicker through the gravel. Okay, thank you. Number 2, explain how this activity helps provide evidence. We like to have evidence, right? In all of our science activities that we do, we're looking for evidence. So this question asks for evidence in the amount of water on the earth stays the same. How does this activity provide evidence that the amount of water on earth stays the same all the time? Rachel.
Well, since we put the same amount of water through each of the materials, we put 13 milliliters
Yes.
through the gravel and also through the sand, but they came out with different amounts in the end, so some of it probably soaked into the sand.
Okay.
as opposed to the gravel, which is bigger and it's more porous.
Porous, that's a good word. Although I don't know how to spell it.
That's how you spell
Is it? There's
it.
two
Yeah, 'cause
U's?
it's pour. You pour something.
Oh, okay.
I think.
Okay, so I still don't see how that is evidence for the water on the earth staying the same. Can you expand? Or can I help?
Well, I said that there was the same amount. You put the same amount in,
Same in.
and different amounts came out. So
And
it
we're
had-
only talking about same. We want to, if we're proving that the water on the earth is the same, it seems like if we put same in, the same should have came out. It didn't all come out. So how is that evidence for it staying the same? If you get my drift.
Well, the amount that comes out has to go somewhere.
It has to go somewhere.
So generally gravel is kind of riverbeds.
If we squeezed all the water out of the sand, do you think it would all come up to be 13 mils in the end?
Yes.
Just find some way to evaporate it maybe.
Evaporate it and condense it back.
The coolest thing to think about is that the water on Earth has been the same water since the beginning of time because it has nowhere else to go. It can't escape our atmosphere. Other than a few kids usually point out to me some of it's in the space station and it has escaped our atmosphere. But other than that, the water evaporates and it goes into the clouds and then it rains back down on us. And this is the water cycle that we studied earlier this year. So this activity actually, I think, doesn't provide a ton of activity for that evidence. So I say activity, a ton of evidence for that. So moving on to the last question, materials such as sand and gravel often contains a small amount of salt, just like on your table. Based on your work in 59, which was a long time ago, I think we might have even still been in school, what do you think happens as water travels through these materials? Rachel?
Well, salt is a soluble compound.
Salt is a soluble. So we're going to have another word. So now we're talking about salt. We don't need evidence either. Salt, like NaCl, like that?
Yes.
It's soluble. That means it
Can
Isn't
be
it
broken down
ionic?
by water.
okay. So it's ionic,
Those are the ions.
it's soluble, and it can be easily broken down,
Easily dissolved.
easily dissolved. So if the question asks, especially when we saw in the video for the two trays, the one on this side had a little bit of like colored water in it, and that colored water is full of minerals and salts from the sand. Because when I pour the water over the sand, some of those little ions, pluses and minuses, come off and they end up collecting in the little pool down here, which is the groundwater. Okay, well, I think that might be it. That was 25 minutes. I think that's it. We've finished our entire handout, and I hope you enjoyed that. And thank you to Rachel. Rachel, do you mind if I put you on screen for a second?
Sure.
Say thank you to Ray Ray.
Oh, you can't see me.
There you are.
Bye.
Bye. Okay, thank you.